everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics, where I am trying to help you to get 60 out of 60 in your physics KCET 2025 exam. And if you are following our channel from the beginning, then you should know that we have already completed a lot of chapters, and all the chapters are available in a single playlist. I will share the details about that at the end of the video. But before going into that, you should know that whenever we are doing a video and doing something new, we are posting that in our WhatsApp channel. The link is given in the description. Don't forget to join our WhatsApp channel and click on the bell icon so that whenever we are doing something new, you are getting the notification. Also, every Sunday we are doing KPL, KCET Premier League, and if you want to know more about KCET Premier League, I will discuss about the syllabus of this week's KCET Premier League end of the video. So till end of the video, please stay with me. Today we are going to discuss one of the most important chapter of your first PU. Okay, so all the other chapters of first PU, generally one question comes from that chapter, but from this chapter average question number is 2. Okay, almost every year 2 question comes, at least one question definitely going to come from this chapter. And even though the chapter is a little bit difficult for KCET exam, the chapter is no longer very difficult because some concepts are already deleted from this chapter. I have discussed this in our physics syllabus video I did a few months back, where I already mentioned that parallel axis theorem, perpendicular axis theorem, these parts are no longer part of the syllabus. So question level from this chapter will be relatively easier because those questions will not come. And tomorrow I will be doing the PYQs of this chapter, so there I will be only doing the questions which are part of the syllabus. So you will see that what all part of the syllabus, what type of questions comes from this chapter. Also during today's lecture I will be solving a lot of questions as well as usual, so that stay with me. And let's start with the first concept, list of concepts. So center of mass, we will start with center of mass, then we will discuss about linear momentum of a system of particle, then we will discuss angular velocity and acceleration. Okay, then we will discuss torque and angular momentum, then we will discuss equilibrium of a rigid body, and then we will discuss center of gravity. Lastly, we will discuss moment of inertia. So let's start with the center of mass. The center of mass of a distribution of mass in space is the unique imaginary point where we can consider the entire mass is located. Okay, imaginary should be in brackets. Sometimes it is imaginary, sometimes it can be a real point within the object. Okay, so first of all the mass we can consider that it is located at that point. Okay, now if it is a mass distribution, so for example, if there are different masses are located at different points, then you have to consider with respect to suppose this is M1, this is M2. Okay, different masses are located at different points. Okay, then you have to use a coordinate system. Okay, coordinate system, that means what, you have to assume there is a y-axis, there is an x-axis. Okay, from there you have to calculate the position vector of individual masses. Okay, everyone will have a coordinate. So suppose this one is x1 y1, this one is x2 y2. In 3-dimensional it will be x2 y2 z2 as well. Okay, it will be this is M3. See, okay, so you have to consider the individual coordinates and then you can calculate the center of mass, right? Now what is the formula for that? The formula for that is XCM. That is, suppose the center of mass is located here. This is the CM. Okay, center of mass, not chief minister, center of mass. Okay, so if this is the center of mass, so basically you can say that at this point, if you consider a mass of having total mass M1 plus M2 plus M3, okay, and whatever motion these individual particles are describing, you can give all the properties at this point, then everything around us will remain unchanged. Then this is called center of mass. So basically, if you remember in our chapter resistance, we tried to find equivalent resistance. right, where we replaced all the resistors using only single resistance, so that the current in the circuit remains the same. Okay, all other components remain same. So similarly, if we replace all the masses using a single mass, so basically you can say this is an equivalent mass. Okay, then that mass having the mass of all the total sum total of all the masses, then that point will be called center of mass. Basically this is the meaning of center of mass. Okay, and x coordinate of the center of mass is given by mi xi divided by capital M. What is capital M? Capital M is nothing but this sum. Okay, and what is the meaning of mi xi? Mi xi is nothing but m1 times x1. So m1 times its x coordinate, okay, plus m2 times x2. Okay, so m2 times its x coordinate and m3 x3, okay, plus m3 x3 divided by m1 plus m2 plus m3. This is the formula for xcm. So this is the x coordinate of the center of mass. Similarly, you can calculate the ycm, that is miyi divided by m. Now here we have only considered 3 particles. There can be 10 particles, there can be 100 of particles. So for individual particles, if they constitute a single system, then you can calculate the center of mass using this formula for all the particles. Right now, as you know, this is going to be little bit difficult, and in case of continuous mass distribution, you can replace this sum sign using a integration. Okay, integration and summation are same, so you can replace this using a integration, but we are not going into that kind of detailed calculations. That is not required for your KCET exam, but you need to remember these formulas. Based on these formulas, questions has previously it was there, and it will going to be coming in your KCET exam as well. Now, the center of mass of a system of particles moves as if all the mass of the system was concentrated at that point. Okay, and all the external forces were applied at that point. So basically what you can do, you can replace all the masses using only center of mass, so that all the sum of all the forces actually is acting on this object. Okay, and it has the mass of all the objects, and acceleration, that means velocity, acceleration, etc. you can individually apply to the center of mass. Now why it is so important? Most of our physics law is based on point objects, right? So we say that force applied on a point, or the tension applied at a point. Okay, velocity of an object. So when I say velocity of an object, I consider that object to be a point mass, right? And we apply the laws of physics based on it is a point mass, right? Now this is very difficult for a very large object to be a point mass. So what about our basic physics? Yes, in terms of actual engineering level, where you are going to study in your future, that even though we are considering point mass, it is not practical. In case of practical applications, you have to consider extended objects, but for our basic physics, okay, so we have to consider everything to be a point mass. So that point mass is nothing but the center of mass. So if you consider everything concentrated at the center of mass, force is acting on the center of mass, velocity of the center of mass, acceleration of the center of mass. So basically you can replace a large object using its center of mass. Okay, so our basic physics laws are applicable to center of mass as well, right? So you can consider this to be individual independent object. Now let's see one question based on center of mass. Two particles which are initially at rest, okay, so initially it was at rest, move towards each other under the action of their mutual attraction. So mutual attraction means no external force is acting on the system. Initially it was at rest, okay, no external force is acting on the system. Okay, so what is the initial momentum? Initial momentum of the system was 0. Okay, so suppose the center of mass was located here. Center of mass, see, this is the MCM. Okay, located here. What is the momentum of the center of mass? The momentum of the center of mass is the momentum of the system, total momentum of the system. So this is the momentum of the center of mass. Now what happens is that now after some time they started moving towards each other, okay, with some velocity. One is moving with v, another one is moving with 2v. Okay, so if their speeds are v and 2v at any instant, then the speed of the center of mass of the system is. So they have asked you to find the speed of the center of mass of the system. Now what is the center of, suppose the speed of the center of mass is say vcm at this point, at this instant. Now we know that linear momentum of a system will always be conserved, right? So whatever the linear momentum at the beginning, the same linear momentum should be there at the end as well, and you can apply this concept individually for the center of mass. Okay, center of mass will always obey linear momentum. Okay, at the initial, whatever linear momentum was there, the final linear momentum should be same. Initial momentum was 0, so final momentum of the, this is say initial PCMI, PCMF will also be 0, right? Because the momentum is conserved quantity, so final momentum will also be 0. Now MCM is not 0, so what is 0? The velocity of the CM should be 0. So as the object initially was at rest, its center of mass, velocity of the center of mass will remain 0. Okay, so basically this gives you an idea that if center of mass initially was at rest, it will remain at rest. That is the law of physics, Newton's first law of motion, right? If something at rest, it will continue to stay at state of rest. So VCM, you can treat it as a independent object. Okay, no matter whatever is happening, as long as there is no external force acting on the system, VCM speed will be 0. So correct answer is option D. This is option D. Okay, not C, option D, 0. Okay, clear? Now let's move on to the linear momentum of a system of particles. The total momentum of a system of particles. So individually what we have done, we have calculated the individual momentum. Okay, now what we are doing, we are doing it for a system of particles where multiple objects, multiple masses are scattered across somewhere. We are calling it as a system of particles. The total momentum of system of particle is equal to the product of the total mass of the system and the velocity of its center of mass. So basically it's a simple concept. Okay, because we have not learned about center of mass so far, so we are reintroducing the concept of this thing. We said that total momentum of the system of particles is basically Pi is equal to mi, total momentum P equals to sum of mi vi, right? If you remember, this was our case. Now what we are saying that, we are saying that this can be replaced by total mass of the system times VCM. This is the condition. This is something we are learning now. Okay, so total momentum of a system can be replaced using the total mass of the system times the velocity of the center of mass. Okay, if the system is already moving, then VCM will not be 0. But if initially it was at rest, VCM will be 0. Total momentum of the system will remain 0. Okay, also we can write that dP by dt. This is the second law of Newton's second law of motion, that dP by dt is equal to applied external force. This is also applicable for center of mass. Okay, so these are the important things, important formulas might be coming in your upcoming KCET 2025, so that's why we discussed it. Now Newton's second law of motion extended to a system of particles as well. So even the system of particles, you are considering a system of particles, you can still apply Newton's second law of motion. Now let's move on to the angular velocity and angular acceleration. This part we have already discussed in our part, but again we are never discussed it individually. So here we are discussing it individually. What is the meaning of angular velocity? Angular velocity is when an object is rotating in a circular path. Okay, so how much angle it subtends in 1 second is called the angular velocity. Its units is radian per second, its symbol is omega, and it is a vector quantity. So how can we determine the direction of this angular velocity? If it is rotating, if we put our fingers in okay, in the direction of the arrow of rotation, okay, if we put our fingers facing the arrow, facing the arrow, if we put our fingers and if I say okay, this is the direction of rotation, this is the direction of rotation, means if our fingers denote the direction of rotation, then our thumb will denote the direction of angular velocity. So angular velocity in this case is omega. Okay, in 2024 exam one question came where you have to apply this concept of direction of rotation. Okay, if it is rotating in this direction, then it is upwards. If it is rotating in the opposite direction, that is in the this is the anti-clockwise direction, right? And if it is rotating in the clockwise direction, then it is downward. Okay, so anti-clockwise upward, clockwise downward. Okay, that is the direction of omega. Now there are two formulas, there are two relationships between angular velocity and linear velocity. So angular velocity can be represented using this formula. So linear velocity equals to omega r. Okay, they are vector quantities, so basically you can write v is equal to omega vector cross r vector, but you will not see this in KCET exam. Maybe in other exam, NEET exam or JEE exam, this question based on this cross product might come, but in KCET exam they are always considered to be perpendicular. In case of perpendicular, the angle is 90 degrees, so for cross product there is a sin theta, sin 90 means 1, so that's why we can generalize them for when omega and r are perpendicular. Right, so this is the basic case. Similarly, linear acceleration can be represented using alpha r. What is alpha? Alpha is angular acceleration. Alpha is angular acceleration. Okay, this is the short way to write acceleration, right? So A is linear acceleration, alpha is angular acceleration. Okay, so these are the simple relationship. I hope you can remember it. Very easy to remember. V is equal to omega r. Okay, A is equal to alpha r. Okay, now let's see one problem based on this question, this concept. Okay, the angular speed of a motor wheel is increased from 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration of the motor wheel is, so they have asked you to find the angular acceleration alpha. Okay, suppose, let's consider this question. An object moving in a straight line, okay, increases its speed from 5 meter per second to 10 meter per second, okay, in 2 seconds. In 2 seconds. What is the acceleration of the object? So how can we calculate the acceleration? To calculate acceleration, what do we do? Final velocity minus initial velocity divided by the time, right? So 5 by 2, that is 2.5. That is in case of linear motion. Okay, so linear motion, this is the acceleration A. Now in case of angular motion, the concept is same. Okay, angular acceleration is same as linear acceleration. Only thing that we need to consider is the angular velocity. Okay, so I will teach you a shortcut method to solve this. First, what we have to do? First, we have to do omega f minus omega I. Okay, omega f minus omega I. What is omega f? Omega f is 3120. What is omega I? Omega I is 1200. Okay, so what is the value of this difference? This difference will come out to be 1980. Okay, you can check, it will be 1980. It will be 1920. Okay, it will be 1920. Okay, 1920. Now this unit is in rpm. So, but the final answer is given in case of radian per second. So this is rpm. How can we convert rpm to radian per second? So first of all, you have to understand what is rpm means. rpm means revolutions per minute. Okay, revolutions per minute or rotation per minute. Now in one rotation, when something rotates one time, how much angle it covers? Okay, so you need to know that when something rotates, this is pi angle, this is another pi angle, so total rotation is 2 pi radians. Okay, in terms of radians, it is 2 pi radians. So when something rotates for one time, it is 2 pi radians. Now rpm to radian per second, you have to convert this after you do the subtraction. Okay, if you do it for individually, it will be longer. Okay, the method will be longer. So it will be 1920 times for one rotation, one revolution, it goes pi 2 pi angle, right? So for 1920 revolutions, the angle will be 1920 times 2 pi. Now there is a minute here, revolutions per minute. So revolutions per second, to calculate revolutions per second, you have to divide it by 60. Okay, you have to divide it by 60. Now do the simplification. 3, 6 is 18, 12 is in hand, so 3 to the 12, 6 to the 12, 32 times 2 pi is 64 pi. So this is the difference in angular speed. So this is the difference in angular speed. So this is by how much angular speed increases. Now what is acceleration, angular acceleration? It will be difference in angular speed divided by the time. Okay, same, delta v by delta t is acceleration, delta omega divided by delta t is the angular acceleration, right? Here time is given 16 seconds. So what you have to do? You have to do it 64 pi divided by basically 16. Okay, so it will be 4 pi. Okay, 4 16 is 64. So correct answer will be 4 pi radian per second square. So if you remember, in the unit of acceleration was meter per second square. Here unit for angular acceleration is radian per second square. Okay, clear? Now let's move on to another problem based on this. This is from KCET 2024 exam that I was saying. So what they have said, a ceiling fan is rotating around a fixed axle as shown in the direction of angular velocity is. So they have given you this diagram and a ceiling fan is rotating. They just simply asked you to find the direction of angular velocity. Okay, so as I said, it is rotating in this direction. Okay, so first of all, what you have to do, you have to put your plane of your palm towards the rotation. Okay, then you have to arrange it such that your fingers points towards the direction of rotation. Okay, so first you face your palm towards the paper. Okay, then arrange your fingers such that it can denote the direction of rotation. So what is the direction of angular velocity? In this case, it is rotating in this direction. So the angular velocity is downward direction. Okay, so angular velocity is in this direction, right? I hope you understand that, how to find the direction of angular velocity, right? Take your hand, face the palm towards the paper, then try to point, arrange your hand either upright or down so that you can arrange your fingers towards the direction of rotation. Keep the thumb separated perpendicular to your rest of the palms, and when you can arrange your fingers towards the direction of rotation, then your thumb will point the direction of angular velocity. Right, so angular velocity will be downward. Now the axes are given here. As you can see, this is the z axis and our omega is in the opposite direction. Right, so this is the direction of omega. Now we know that the unit vector along z axis is k cap. So along the negative z axis it should be negative k cap. Right, so the answer should be in this case is negative of k cap. So minus k cap should be the answer. Right, so this is the question from KCET 2024 paper. You can understand that KCET 2024 paper was not so easy, but still this question you can solve in less than 10 seconds. So if you have studied all the chapters of your first PU, okay, question level is relatively easier for your first PU. So many students are thinking, I will only complete second PU, I will answer 45 questions and I will get a good rank. Not possible, boss. If you are preparing for KCET with heart, then you have to prepare your first PU. Question level is relatively easy, and with Salpa effort you can score a very good marks. Okay, let's see the next part. Next part is torque and angular momentum. Another two concepts relatively difficult, but trust me, not so difficult if you are preparing for KCET exam. Okay, the rotational analog of force. So basically if you remember laws of motion, which is a very basic chapter, there is something called force. Force is what? Which changes the state of rest or state of motion. Similarly, thing that changes the state of rotation is called a torque. Okay, torque basically rotational analog. Analog means same thing. When something is rotating, something in linear motion, if force, whatever force was doing, same thing was done by the torque in rotational motion. Okay, analog means comparison. Okay, I will do the detailed comparison of linear motion and rotational motion, but this is called rotational analog. Analog means comparable. Okay, so whatever role it was playing in force was playing in linear motion, the same thing was played by torque in our rotational motion. Okay, so I give you one simple example. Okay, there was a movie. Okay, it was produced in Hollywood. Okay, and that movie was remade into a Hindi movie by some renowned actor. Okay, so whoever played the main character in the Bollywood movie, okay, the same character was played by someone else in a different in Hindi movie. The name was changed, but the story is the same. Right? Similarly, you can consider that the laws of motion is a Hollywood movie and rotational motion is a Hindi movie or a Kannada movie, where same character is being played by a different actor. The name is different, the character name is different, but the entire thing, entire story is same. Similarly, here in rotational motion, whatever is torque is doing, the same thing was done by force in case of linear motion. Okay, that is the thing. Okay, it is also referred to as torque or couple. Okay, torque and couple are same thing. Okay, also it is called moment of force. So moment of force, torque, couple, they can be interchangeably used. Okay, sometimes you will heard moment of force. Okay, what is moment of force? Moment of force, torque, couple, they are all the same thing. Okay, and the formula for torque is R cross F. Okay, if you remember, in case of velocity it was V is equal to R omega. In case of torque it is little bit reversed. Okay, torque is coming first and R and F are getting multiplied like this. Okay, so as you can see, this is a vector quantity, and in scalar form you can write tau is equal to, this is tau, this is called tau, this is like a small t, R F sine theta. Now in this case they are not necessarily to be perpendicular. In case they are perpendicular, obviously sin theta becomes 1, so you can write tau is equal to RF directly. Okay, now the quantity angular momentum is the rotational analog of linear momentum. Simple thing is that. Okay, in linear momentum we use something called MV. Angular momentum, it is not MV, it is something else. For about that we will discuss in a while. Okay, so the angular momentum is basically the same thing which is represented in rotational motion. Okay, also one important thing that I want to discuss here, that like linear momentum, okay, which is a conserved quantity, we know there is a law of conservation of linear momentum. Similarly, angular momentum is also conserved. Okay, so angular, if you add angular momentum of a system, okay, it will remain constant. Okay, if it is not rotating at the initial stage, then its final angular momentum will remain 0 as long as no external force is acting on the system. Okay, total momentum of a system total angular momentum of the system will remain constant as long as no external torque is acting on the system. Okay, you have to remember external torque. In case of linear motion it was force, in case of rotational motion it is torque. Okay, now the time rate of total angular momentum, okay, of a system of particles about a point is equal to the sum of the external torque acting on the system of system taken about the same point. So basically in this case, in case of rotational motion, you have to mention the point. Okay, about the point, because it is rotating, right? So it is rotating means there has to be some point about which it is rotating. So that is why the point, the axis, that is important in case of rotational motion, which is not required at all in case of linear linear motion. So that is one difference from rotational motion and linear motion. Otherwise, all the formulas, all the laws are similar. So this is the second law of Newton's second law, equivalent in rotational motion. What is the meaning of that? Tau, torque, is basically equals to time rate of change of angular momentum. Okay. So if you remember, in linear motion, force was equals to dp by dt. Similarly here, torque is equal to dl by dt. L is angular momentum. Angular momentum is denoted by the symbol L. Okay, angular momentum is denoted by the symbol L. Okay, so this is one thing that we have seen. Equilibrium of a rigid body. So if I say a rigid body is in equilibrium, so far, okay, equilibrium means only linear. We have only considered the linear forces. Okay, we have not considered any rotational forces, especially those who are going to appear for JEE mains exam, those who are going to appear for JEE advanced exam. You have to be careful about what is the meaning of equilibrium. There are a lot of questions every year, at least 1 or 2 questions comes from this, the concept of the equilibrium. If I say the object is in equilibrium, that means total force acting on the system is 0. Total torque acting on the system is 0. Okay, now you might say, sir, if the force acting on the system is 0, then torque should automatically be 0. Not necessarily. So for example, if I apply a force, say here, okay, F in this direction and another F in this direction, what is the total force? This is positive, suppose this is negative, so total force should be 0. But is the torque 0? The distance is not 0. The perpendicular distance between the forces is not 0. So if the perpendicular distance between the forces is not 0, torque is not 0. Torque is R cross F. Any one of the F's and the perpendicular distance between them. Right? So RF is not 0. So torque is not 0 in this case. But total force is 0. So it is not necessarily to be true that if total force is 0, torque will also be 0. No. Torque may be 0, torque may not be 0. Okay, but in case of equilibrium, if I say an object is in equilibrium, then total forces, all the sum of forces should be 0. Okay, and the total torque, that is the vector sum of all the torques. So this is not simple addition, this is a vector sum. Okay, vector sum of all the torques acting on the rigid body has to be 0. Okay, so sum of torque should be 0. So you calculate what F1, F2, F3, F4, take all the direction of the velocity of the all the vectors, vector forms, okay, and then add them, then you will get the sum to be 0. Now one more thing, what is the direction of torque, you might say? So it is basically R cross F. So if you start from R and take any direction of which force you are doing, so suppose you are this is your R. In this case, okay, F is going up, so R cross F will be in this direction. So R cross F in this direction, so the torque will be upward direction. Okay, so basically you have to consider what is the direction of R, what is the direction of F, and if you move your fingers from R to F, whatever your thumb will point out, that will be the direction of the torque. Okay, I hope you are familiar with vector multiplication. If you are not, then you can check my chapter when I did the vector chapter, where I discussed briefly about multiplication of vectors, cross product and dot product, even though I have not discussed cross product in detail because not so many questions comes from this concept. But in this chapter there is a chance that 1 or 2 questions might come based on the cross product concept. There was one question in previous year questions that came from this cross product concept. We will discuss that in our next video, where we are discussing all the previous year questions. Now, center of gravity. So we have already seen that center of mass. So we consider all the masses concentrated at a single point and we called it center of mass. Now what is center of gravity means? Okay, the CG or center of gravity of a body is defined as the point where total gravitational torque on the body is 0. What is the meaning of that? Suppose I have an object. Okay, I have an object. Individually you can consider this object to be sum total of small masses. Okay, small masses m1, okay, and individually all the objects are experiencing some gravitational pull, right? All of them are experiencing some pull. Now if you consider one point, okay, and if you take addition of all the forces, okay, and then if you take the torque at this point, if you consider the torque acting on this point, and if you add them all the vectors of this individual torques, okay, you can consider there will be a there will be a reactionary force for each individual forces. So if you consider the torque of the entire object, entire body, okay, there will be a point where the torque will be 0. Okay, so if the torque at that point is 0, that point is called center of gravity. It is a unique point for an object, okay, and it depends on the few things. We will discuss that. The center of gravity of a body coincides with the center of mass, okay, in uniform gravity. So if the gravity is uniform, okay, we know that gravity is not uniform. Gravity varies from place to place, altitude, longitude, okay, and height. Okay, height means altitude, then there is longitude and latitude. Based on latitude, longitude, we know that gravitational pull is maximum at poles, minimum at equator. So based on different location, gravity varies. So gravity, even if I say gravity is almost constant here and here, but there is a very small difference between gravity of here and here. Similarly, if I consider height, the gravity varies also significantly. So if the gravity is uniform, almost uniform, and if the object is small, okay, for small objects gravity has to be uniform. There is no other option, right? So if I consider a small object, okay, the gravity will be uniform for this object, for all the points. But if I consider a very large object, okay, gravity will not be uniform for the large objects. Okay, so if the object is small, okay, compared to the size of the earth, that is important. If the if the size of the object is small compared to the size of the earth, then we can say that this is the center of mass and center of gravity are at same position. But conceptually these two are different. Okay, conceptually center of gravity and center of mass are not same. Okay, center of mass basically comes from the concept of forces, okay, and concept of gravity comes from the concept of torque. Okay, this is the basic difference. Okay, and there is no direct relationship between center of mass and center of gravity. Be clear about that. But because of geometry, in some cases center of mass, center of gravity do coincide. Okay, if it is a uniform object and if the gravity is also uniform, then center of gravity and center of mass will coincide. Okay, this is one point to remember. Now let's see one question based on this KCET 2024. The center of mass of an extended body on the surface of the earth and its center of gravity can never be at the same point, are always at the same point for any size of the body. Okay, the center of mass coincides with the center of gravity of a body if the size of the body is negligible compared to the size or radius of the earth. Okay, are always at the same point only for spherical bodies. Okay, they are the same point for spherical bodies, but not only for. This is what makes this option wrong. Okay, can never be at the same point. No, wrong. It can be at the, we have seen that as we have discussed, are always. No, not always as well. And as we say that center of mass coincides with the center of gravity of a body if the size of the body is negligible as compared to the size or radius of the earth. So this is the correct answer, that if you can neglect the size of the object compared to the size of the earth, then their center of mass and center of gravity will coincide. Okay, even though they don't have any direct relationship. Now let's look into another important concept from this chapter, which is moment of inertia. This is a very interesting concept, and as I said that in case of linear momentum, we said linear momentum is given by mv. Okay, angular momentum is denoted by something which is equivalent to mass in rotational motion times the angular motion, angular velocity, right? So what is this quantity? What is this mysterious quantity? That mysterious quantity is moment of inertia. So if you remember what is inertia, inertia was when we try to move one object, okay, that object gives us some resistance. We defined that resistance to be inertia, okay, and later on we found out that that inertia is nothing but mass, okay, inertial mass, sometimes we call it inertial mass, okay, or normal mass. Similarly in rotational motion, if we try to rotate something, it does not rotate freely, it try to stop us. So that thing is called moment of inertia, okay. So moment of inertia is the analog of mass in rotational motion, okay. In rotational motion, whatever role was played by mass in linear motion, same role is played by moment of inertia in rotational motion. It is denoted by a symbol I, okay, it is denoted by a symbol I. So that mysterious quantity that I was talking about is nothing but I, okay. It depends on different things, we will see that, okay. It is not constant like mass, where we can say, okay, if m is the mass, then it is constant for everything, but moment of inertia varies depending upon certain conditions. And you have to remember a table, at least a few objects, which is very frequent, very common, okay. I will show you that. And one more thing is important term is radius of gyration, okay. Radius of gyration, some call it gyration, okay. Gyroscope, whatever you are already familiar with. Radius of gyration, both are correct spelling, okay, based on which part of the world you are from. I will say radius of gyration, okay. So radius of gyration is the radius of gyration of a body about an axis, may be defined as the distance from the axis of a mass point whose mass is equal to the mass of the whole system, whose moment of inertia is equal to the moment of inertia of the body about its axis. So what is the thing? Suppose I have a body, it is in rotational motion about some axis, okay, and if this body is rotating about this axis, there will be a moment of inertia of this mass. It's a random mass, it will have a moment of inertia, right? Similar to that, a random object will have a mass, any random object will have a moment of inertia. Now if I want to replace this entire body using a single point mass, whatever the total mass of that system, we do not the same mass of that system is here, as well as whatever the moment of inertia of that object, same moment of inertia is here, then this distance is called radius of gyration. Okay, basically what we can do, we can replace any extended object using this point mass, then that point mass, the distance from the axis is called radius of gyration. So you can say that radius of gyration is similar to center of mass, only thing is it is only for rotational motion. Okay, so only thing is that this is only for rotational motion, the distance, and also it depends on the axis as well. Okay, so it depends on the axis as well, where you are putting your axis, based on that radius of gyration can change. Okay, whereas in case of center of mass, it only depends on the position of the individual masses. In this case, it is dependent on the axis as well, very important thing. Okay, and normally if suppose this is radius of gyration is denoted by a symbol K. Okay, if moment of inertia is I, mass of the object is m, then I equals to mk square. This is a simple formula. Okay, sometimes if we know the radius of gyration and if we know the mass of the object, we can calculate the moment of inertia of the object. This is one of the application of radius of gyration. Okay, now let's move on to next part. Moment of inertia depends on few things that I was talking about. It depends on the shape. So it depends on how the object is shaped. Okay, like unlike mass does not depend on shape. Okay, it depends only how much matter is inside that shape, but moment of inertia depends upon the shape. Okay, depends on the position of the axis of rotation, how the axis is rotated. It's like this, like this, like this, how the axis is pointed, okay, how the axis is positioned. Based on that, moment of inertia can change. Depends on the size, big, small, how big is the object, how small is the object, depends on the size, and it depends on its mass as well. Okay, so it depends on these four important things: depends on the size, depends on the shape, and depends on the mass as well as position of axis of the rotation. Now let's move on to the next part. This is a very important table to remember about moment of inertia of different objects. Here are few examples. Here is a ring. Okay, ring is very simple to remember. It is mr square. Okay, it is important to remember the moment of inertia of a ring. Okay, moment of inertia of the ring when you are considering the central axis. Now one important thing I forgot to mention, that moment center of mass of an object can be located outside the object. Okay, so for example, if you consider this ring, all the mass of the ring is located inside the ring only, but its center of mass is located somewhere in the middle where no mass is there. This is something that I forgot to mention, that center of mass can be located where there is no actual mass, no real mass is located. So that's why it is sometimes it is imaginary point. Okay, it is not inside, it does not need necessarily to be inside the object always. Okay, inside the mass where the mass is located. So for example, here we are considering this is the VCM, and if we consider an axis passing through VCM but it is perpendicular to the plane of the ring, then its moment of inertia is given by mr square. Now if you rotate the disc, okay, now if you try to rotate it like this, so initially what you are doing, you are trying to do a hula hoop. You have seen hula hoop, right? So you are rotating in this direction. Now what you are doing, now you are doing it like a flip, a coin flip. So now if you rotate the same thing in like a coin flip direction, like this, in this axis, along this axis, okay, then its moment of inertia will change and it will become mr square by 2. Okay, similarly for a rod, it is ml square by 12. Okay, so rod perpendicular to the length of the rod, it is ml square by 12. You have to remember at least few examples. This is these all 5 are very important. Okay, there are few more, but for KCET exam I have never seen any question coming from those things. We will show that as well, but these 5 are very, very, very important. Okay, so especially this circle one and this rod one. Okay, and this complete disc. This is a complete disc. Okay, there is, in case this is a ring like the thing that you wear, like this one. Okay, and this is a disc, the CD that you see. Maybe you have used CDs or DVDs. In our generation that was very popular. So CDs and DVDs, like this, a solid flat circular piece. Okay, in that case the moment of inertia is mr square by 2. And the same thing when you do it like this, then it becomes mr square by 4. Okay, these are the very, very important 5 moment of inertia that you have to remember. Okay, for ring ml square by 12, for circular disc, circular ring, about the axis is mr square, about the axis toward along the plane of the disc, it is mr square by 2. Okay, for circular disc it is mr square by 2 already, and for disc along the plane it is mr square by 4. So if you remember this one, you can remember this one as well. Okay, and other you have to remember this. So if you remember 4, you can remember 5. Okay, so this is the trick. Now this is the second half of the list. Okay, here this one are optional, you don't need to remember it by heart, but if you are preparing for JEE or NEET, maybe question based on this as well are important, especially the sphere one. Okay, 2 by 5 mr square. Okay, cylinder one, I have it is not very common, but you can still remember it is again mr square by 2 if the cylinder is solid. Okay, and if you are rotating along the axis, okay, for a hollow cylinder, okay, it is mr square. Okay, but if you try to remember everything, it will be confusing for you, so I request you don't need to remember these 3, but other 5 you have to remember very carefully, okay, for KCET exam. Okay, now let's move on to the next part. Now, as I said, there was a comparison between linear motion and angular motion. Let's see, in linear motion we represent displacement. When some object moves from one place to another, it is called displacement, and it was represented by the symbol x or sometimes s. Okay, s is also displacement. In case of rotational motion, it is angular displacement. Okay, and it is denoted by angle symbol theta. Okay, velocity is given by dx by dt. Angular velocity is given by omega equals to d theta by dt. Same thing. Okay, acceleration is given by dv by dt. Angular acceleration is given by alpha is equal to d omega by dt. Okay, mass is m. Here it is moment of inertia. Okay, force is F is equal to ma. Here torque is tau is equal to I alpha. Okay, work is dw is equal to f ds. In this case, work is tau d theta. Okay, now here work and work are same. Here it is not angular work. Okay, so that is the difference. Now only up to force there are some equivalent quantities. After that, if you see, all the quantities are same, only formula is different. So kinetic energy is half mv square, it is half I omega square. Okay, power is F times V, power is tau times omega. Okay, linear momentum is P is equal to mv, angular momentum is L equals to I omega. Right, I already discussed that. Right, so this is also a separate quantity. Okay, linear momentum, angular momentum. These 3 are related to work, energy, power. These 3 quantities are same, only the thing is formulas are different for linear and angular. Okay, same. Okay, half mv square, it is a half I omega square by 2. Sorry, half I omega square. Same thing, only thing that is you have to replace mass with moment of inertia and velocity with angular velocity. Okay, similar things, everything is very, very similar. So if some question comes from rotational motion and this chapter, you are 100% sure you can answer that question. Okay, if you practice a little bit more. Let's see one more question from KCET exam. Okay, this came in 2015. Moment of inertia of a thin uniform rod rotating about the perpendicular axis passing through its center is I. Okay, so moment of inertia of uniform rod. So rod, okay, passing through the axis is moment of inertia, it is rotating, suppose this direction. Moment of inertia is given by I. If the same rod is bent into a ring, so same rod, suppose the length of the rod is L. Now what you have done, you have bent the rod into a ring. Okay, and the moment of inertia about for this rod is I dash. So what you have to find is the ratio of I by I dash. Okay, so moment of inertia about its diameter. So about its diameter means this is the about its diameter. Okay, about perpendicular to the diameter means this is the perpendicular to the diameter. Here they have said about its diameter. Now what is the, first of all let us see how these two things are related. There was a rod of length L. You take that rod and you bend it to a circle. Okay, so suppose the radius of this circle is now R. What is the relationship of R with L? Both of them, if you cut this and make it straight, it should be L, right? Because you have taken that rod and then you have bent it to make it through a circle. So what we can say that the perimeter of this circle should be equals to the length of the rod. That is the first point. So what is the perimeter of the circle? Perimeter of a circle is 2 pi r, and that should be equals to the length of the rod. This is the first relationship. Okay, so from here we can calculate r. R is equal to L by 2 pi. Okay, now what is I for a rod? For a rod, I is, we have seen that is 1 by 12 m L square. right? This is the moment of inertia for a rod, right? Now what is the, it is, you have converted into a circle. Okay, so basically it's a thin ring, right? So thin ring, what is the moment of inertia of a thin ring? Moment of inertia of a thin ring is half mr square when you have bent it to form a ring, okay, and along its diameter. If it is along this direction, then it will be simply mr square. But because you are measuring the moment of inertia along the diameter, it should be half mr square. Okay, now put the value of r that you have calculated, right? Or you can do one more thing. Okay, instead of doing, because we are trying to find the ratio, don't do this. What we will do, we will put the value of L in this equation. So basically 1 by 12 m times 2 pi r whole square. Okay, or this equals to 1 by 12 m times 4 pi square r square. Okay, so it will be cancelled, it will get 3 here. Okay, so 1/3 m pi square, or let me write it little bit simpler way, because mr square should be common. So let me write pi square by 3 mr square. Right, now what they have said, this is I dash. They have asked you to find I by I dash. Okay, so I by I dash will be equals to, as you can see, mr square will be cancelled. Okay, this is I dash, this is I, but here it will be pi square by 3 divided by half. mr square will cancel, and this is in division and again in division. So dividing by divide is multiply, so it will become 2 pi square divided by 3. Okay, so 2 pi square divided by 3, this is the correct answer. Okay, very interesting question. If you remember these two formulas, simple formulas, then you can solve this question like this. Okay, so that's what I was saying. This chapter, if you study properly, the question level is little easier. So also don't get disheartened if you are preparing for JEE as well and you think, okay, this chapter is very difficult for me. Actually for KCET, this chapter is not so difficult comparatively from other chapters. Okay, the question level is relatively straightforward. Apply the formula, solve the questions, then you can answer these questions. Also, as I promised in the beginning, there are two things that I want to say. This week's KCET exam, KPL exam. So this week's KPL exam will be based on work power energy, okay, and system of particles and rotational motion. Also second PU, from your second PU, current electricity. Okay, these three chapters combined will be the syllabus for your this week's KPL. Okay, KPL number 11. Also, all the chapters we have completed, all the topics that we have covered. We have not been able to cover that in a single video, so sometimes the chapter is long. We have broken that chapter into smaller videos so that you can watch them at one go. Okay, and everything is available in our channel, in our KCET 100 days challenge, physics 100 days challenge of 60 out of 60. All the videos are available there and it is getting updated every day. Okay, this screenshots are very old, okay, but the chapters and all the videos are getting updated every day. Okay, we have already uploaded, I think, 54 videos so far. This is 55th video, okay, excluding KPL. Okay, and all things happening in our WhatsApp channel, so don't forget to join our WhatsApp channel if you have not yet done so. The link is given in the description, and if you are watching this video for the first time, don't forget to subscribe to our channel and give it a like. If you have liked this video, I will be back with the system of particles and rotational motion previous year questions very soon, tomorrow. Till then, bye.